Newton's third law is often stated this way: for every action there is an equal and opposite reaction. We already know that an object can only experience a force because another object is present to apply it. Newton's third law now tells us that whatever force one object applies to another, the original object applies the same force right back. So we might describe Newton's third law this way. If object 1 applies a force to object 2, then object 2 applies a force back to object 1 that is equal in magnitude and opposite in direction. This statement sounds simple enough, but it isn't always our instinct. Here are a few quick examples. A hammer hits a nail. The force that the hammer applies to the nail is equal in magnitude and opposite in direction to the force that the nail applies to the hammer. Here's another example. A bat hits a ball. It doesn't matter if one object is initially moving faster than the other object. The force that the bat applies to the ball is equal in magnitude and opposite in direction to the force that the ball applies to the bat. And another example. A baseball is thrown into the air. Newton's third law applies to all forces, even field forces like gravity, and it also doesn't matter if one of the objects is a whole lot more massive than the other object. So the Earth applies a gravitational force to the baseball that is equal in magnitude and opposite in direction to the gravitational force that the baseball applies to the Earth. So if the forces are the same, why is the baseball clearly affected by the gravitational force of the Earth, but the Earth doesn't seem to be affected by the gravitational force of the baseball? It's because of the differences in their masses. Each object responds to the force acting on it according to Newton's second law. Let's follow this through, starting with Newton's second law, which we can apply to the y direction, and then putting in the gravitational force, and finally solving for the acceleration. We can now apply this result to the ball or the Earth. The FG's are the same, but the mass of the baseball is relatively small, so we get a relatively large acceleration for the baseball, while the mass of the Earth is extremely large, so we get an extremely small acceleration for the Earth. So we can see that the Earth is affected by the gravitational pull of the baseball, but its acceleration is just too small to notice. And one last example. A car hits a bug. The force that the car applies to the bug is equal in magnitude and opposite in direction to the force that the bug applies to the car. It doesn't matter if one object is bigger or faster or survives the interaction better. There are no exceptions, no special conditions. Forces are always between two objects, and they always come in equal and opposite pairs, no exceptions. Okay, so that's Newton's third law. There's also a worked out example posted on Moodle that involves the bug and the car scenario, and I recommend that you view that as well.